Okay, so I'm going to pick up where we were the last time in class with the prisoner's dilemma. I'm going to go over how to solve the game again, and then I'm going to talk about some potential solutions. That's where we left off actually the last time that we were in class. So again, prisoner's dilemma game. We have two people get arrested over the weekend, two friends, we'll call them friends, and they have a choice to make: cooperate, don't cooperate. Cooperate means that you tell the police exactly what happened. Don't cooperate means that you shut your mouth. And we know that these two players are separated and are not communicating with each other. So, again, remember, the payoffs to the left of the comma are for player 1. The payoffs to the right of the comma are for player 2. So one thing to notice is that you should never try to solve the game just by looking at the grid. You should never say, okay, well, this is better than this, and so therefore this must be the answer. There's a specific way that we're going to solve the prisoner's dilemma game. Actually, this is a specific way that we're going to solve any game theory game in this type of matrix formation. So how do we do that? Number one, we say if I'm player 1 and player 2 doesn't cooperate. So if I'm player 1 and player 2 doesn't cooperate, I look down the column, 10 years in prison versus 5 years in prison. 5 years in prison is clearly better. Second question, if I'm player 1 and player 2 cooperates, look down. 1 year in prison is better than 2 years in prison. And you're going to want to be underlining these things as you get the solution to each question. Question 3, if I'm player 2 and player 1 doesn't cooperate, this is where it gets a little tricky. When you start with the third question, you now have to look across and you look to the right of the comma to see the payoffs. So this is if I'm player 2 and player 1 doesn't cooperate, 10 years, 5 years, 5 years. Finally, if I'm player 2 and player 1 cooperates, 2 year, 1 year, 2 years, 1 year, and 1 year. So anywhere, any quadrant where we have both of the numbers underlined is going to be our Nash equilibrium. So in this case, we have 5 years in prison for each player. The reason we call this a dilemma is because this is clearly a better place to be for both players, but we're stuck here. So the question is, how do we get from this quadrant to this quadrant? Notice that playing cooperate as a strategy is really risky. Because if you cooperate, but your opponent, your rival, your friend, whatever you want to call them, doesn't cooperate, you risk going to prison for 10 years. And so there's so much risk in choosing cooperate that we usually are going to predict that we get stuck in this bottom right quadrant, which is why we call it an actual dilemma. So the question is, how do we solve this dilemma, or how do we at least partially reduce the problem of the prisoner's dilemma? And we see the prisoner's dilemma in the business world, in joint ventures, and other things we'll go through in class the next time we actually meet in class. So how do we solve this? Well, one way that was suggested at the end of the last class was through communication. What if the two players could communicate with each other and tell each other, hey, I'll cooperate if you cooperate, and therefore we'll each get 2 years in prison. So what I want you to do right now is I want you to stop this video as soon as I'm done this sentence. I want you to stop this video. I want you to go into Angel, into the readings folder, and I've put there a link to a YouTube video. This is a YouTube video of an actual game show with real money, and it parallels the prisoner's dilemma with communication. So what I want you to do is I want you to stop this video, watch that video, and then ask yourself, can we reduce the prisoner's dilemma with communication? Okay, so right now stop and don't go further in this video until you've actually watched that YouTube video. Okay, so I'm going to assume at this point that you've stopped my video, watched the YouTube video, and clearly we know that communication is not going to be a solution to the prisoner's dilemma. It may reduce it, sometimes it may be a solution, but in general, communications is not going to be a solution to the prisoner's dilemma. There are a couple actual solutions. I'll talk about two, one that's kind of minor and one that's pretty major. One is bonds. Okay, so for example, if, again, I don't know why it keeps coming up with being arrested, but imagine you're arrested and you are given bail by a judge. You issue a bond, you buy a bond, which is 10% of your bail amount, and the point of that bond is to bond you to the court system to make sure that you're going to show up at the next hearing or whatever it might be. In the business world and in other types of situations, we can have bonds that bond each player to a specific quadrant, so to a specific strategy. For example, if two companies are going to form a joint venture and each player isn't sure if the other one is going to actually contribute the resources that they're supposed to contribute, they can have a bond such as one company may contribute a factory to the joint venture so that the other player is assured that the other player, the rival, is going to make sure that they put all the resources in. And we'll go over different types of bonds the next time we meet and we talk about game theory and we do our simulation. So just know that a bond is a type of solution to the prisoner's dilemma. We'll go over that in more detail, but it's not as important. The one that is important is reputation. Or trust. We'll call it trust or reputation. And in game theory, reputation means that we're going to have a repeated game. We're going to keep playing the game with each other, and therefore we're going to wind up at an equilibrium that's better because we know that in the future we're going to meet again. So for example, if a buyer and a supplier are going to consistently interact with each other, theory would predict that they're going to go into the prisoner's dilemma, but the reason that we see that they don't all the time is because they end up having reputations with each other because they keep playing the same game over and over. Same thing in a joint venture. If every year we're going to be in a joint venture together, we're going to make sure that we contribute enough to get to a better equilibrium until one partner says that they're going to not be in the joint venture or not be in the buyer-supplier relationship. So what you want to know is that reputation or trust is going to be our solution to the prisoner's dilemma game. And when we meet for our simulation the next time we physically meet in class, we'll go team by team and play the prisoner's dilemma game with other teams in the class, and we'll see if the theory works out or if the solution works out. Okay? I'm going to also post questions with this video. Make sure you answer those questions and send them back to me by Thursday at 11:59 p.m. See ya.